Hello, hello. Welcome to Byteconf React Native for the session on building real-time offline-ready mobile apps with React Native and AWS. My name is Nader Dabit. I'm a developer advocate at AWS Mobile. I'm also the co-founder of React Native Training and the author of React Native in Action. I've done a lot of stuff in React Native over the past couple of years. And you can follow me on Twitter at Dabit3, also GitHub and Medium. I am Dabit3 on pretty much all of my social networks. So today we're going to be talking about one major philosophy that will kind of apply to the actual example that we're going to be building out. And this philosophy is around the idea of developer velocity. When I first started using React Native in general, it was because I wanted to be more efficient. I wanted to be able to do more with just learning the minimal amount of things and being able to do more with that, right? So kind of React Native fits into that. And really in my entire career, I've kind of focused on this, learning something and then trying to apply that knowledge across multiple fields. That way you spend less time learning and more time being productive. And really there are different levels of what kind of this thinking relates to in the terms of what you might be interested in or what you might be able to relate to. At a very high level, one of those is JavaScript. So JavaScript is something that allows developer efficiency. You learn a single language. You're able to build not only web applications these days, but also desktop applications. Of course, you're able to build server-side applications. You can do machine learning now. Of course, mobile. You can build for targets like the Apple Watch. You can do all types of stuff just by learning the single language. A lot of other languages don't allow us to do this. So kind of adopting JavaScript puts you in this category at a high level of being efficient. And if we dive a little deeper, we can talk about React and React Native. Learning React allows you to, again, use a single framework and deploy across multiple targets. Of course, we know iOS and Android, and now you can do React Native Web, which is a little different than React Web. And of course, desktop and a few other different targets that are kind of out there these days. And then, GraphQL, this is kind of something else that kind of falls into this paradigm. When you're building a GraphQL application, the way that GraphQL works is you're able to introspect the schema and know exactly what type of database operations or what type of operations in general you're able to use to execute. So you can look at the queries, mutations, and subscriptions. You can also look at the types. You know exactly the type of data that's coming back. Also, GraphQL is real-time. So if you're building a server, you don't actually have to spend time implementing subscriptions yourself or actually real-time yourself, doing WebSockets or something. GraphQL, of course, has this idea of subscriptions, and it's part of the specification. So this allows developers, again, to kind of be more efficient when they're building their APIs. When I joined AWS Mobile because I saw some of the tooling that they've been working on, and we've had really a lot of success with it over the last year. We're ramping up even more for 2019, and we're going to kind of touch on some of those specifics here. Two of the main products, tools, projects in general that I work with are AWS Amplify and AWS AppSync. And that's what we're going to be using today to kind of demo the application that we're going to be building from scratch. AWS Amplify is a few different things. It started off as just a client library, but now it's a lot more than that. We've added a CLI that allows you to spin up cloud-enabled services from your command line. We've also added a feature that allows you to do multiple environments. So you can create different dev, prod, those types of environments by spinning up entire copies of your infrastructure. We've also added a console recently that allows you to deploy and do continuous integration via GitHub with kicking off new builds whenever your branches get merged to master and those sorts of things. And we also have a toolchain that allows you to do things like GraphQL code generation, which we'll look at in just a moment. So that's Amplify. And then the other thing that we work on is AppSync. And we'll go into exactly what AppSync is in just a moment and take a look at it. But really the idea that we're focusing on is bringing full stack to front-end developers or to client-side developers and allowing them to use their existing skill set to build these robust and full stack web and mobile applications without having to understand all of what there is to understand when you're building secure backends and scalable backends. So a lot of what we're going to be talking about today revolves around the idea of serverless. And when you talk to different people about what serverless means, you'll probably get a lot of different answers. But to me, this is a good definition. There's no servers to manage. So a serverless application is something that just runs and you don't really have to worry about it. It continues to scale for you. It scales and balances for you. You don't have to worry about if you get 1 million users having to deal with that capacity. It automatically just continues to work. That's all on the cloud provider that you're working with. You only pay for what you use. You're not paying for any reserve time that's not being used. So you can build things and not really have to pay so much until you actually get a lot of users. And then there's less code to manage. This is one of the main things we're going to be focusing on, this idea of less code to manage in general. When you think of serverless, a lot of times people think of Lambda functions. And when you think of Lambda functions, you probably think a bunch of different Lambda functions maybe calling each other. Like this is what a lot of people think of when they think of serverless applications. I saw a tweet from Joe Emerson, and this was a really interesting tweet to me. Instead of a collection of functions calling each other, the best serverless applications have 3 main properties: a thick client code handling all of the interaction logic, heavy use of managed services. The managed services we're going to be looking at are going to be AWS services, but this idea goes into any cloud provider or any application. It doesn't have to be specific to AWS. So services like AppSync, like Auth0 for authentication, Algolia does search, Cloudinary, and there are a bunch of others out there. And then whatever you can't handle with these managed services, you then offload to the glue functions, which would be what you would typically think of as Lambda functions. And one of the key benefits is not that there's no servers to manage when you're talking about this idea of serverless. It's actually that there's no backend code hardly at all that you have to deal with. And less code, of course, means less liability. So when you think of serverless in the sense of what we're going to be talking about, I'm kind of focusing on this idea of less code, more abstraction versus building a bunch of functions in the cloud. So when I say serverless, I'm going to be kind of really meaning this idea of a serviceful serverless. So it's this serverless, we're kind of taking all of the ideas that go into serverless and we're adding additional things that we're kind of going to be using as services. So we're calling it serviceful serverless. And what are some properties of what this means or what this is? Again, we have no server operations. We also have the scaling and we have the low code. But we also have this main property of assuming responsibility for providing a defined set of services. This is kind of the main differentiator between serverless and serviceful serverless. You're basically hooking into or subscribing to their defined way of doing things, and you're consuming their API. You don't have to build this yourself. You're just kind of taking advantage of something someone else has built. And again, you might have used something like Auth0 in the past or maybe Firebase. These kind of go into that same category. A few of the main reasons why you might want to do this. First of all, you end up with, instead of a capital expense, you end up with a variable expense. So for instance, instead of paying a developer 30 grand to build out this authentication service or build out this API, you don't know if it's going to work yet, you just want to maybe test it out. A variable expense would be hooking into an existing service that does this already, and you don't really pay for it again until you start having users. So you're only paying for what people use versus actually building out the product again. A long time ago, when electricity was first invented and you needed to build something like a factory or something like that, back in the day, you might have to actually build and maintain your own power plant when electricity was first invented. These days, we consume electricity as a commodity. When we walk into our house, we turn on a light switch, we pay for the electricity we use, we don't have to worry about much else. That's the way that you can think of these managed services and serverless in general. You have these services available to you and you just pay for them as they're being consumed versus paying for the upfront cost of creating them. Less code. Less code means more maintainability, less liability, easier to go and make changes to because you just have less stuff to deal with. There's this quote that I found that I kind of edited a little bit for this slide. Go for an application that any idiot can manage and can maintain, because sooner or later, any idiot is probably going to maintain it. And sooner or later, that idiot is probably going to be me or you, right? Because when we go back to code we wrote 12 months ago, a lot of times it takes us a while to get up and running with exactly understanding what we did there. Also, if your application is successful, you would like to probably hand this off to someone to manage it for you, or maybe you'll be promoted within your company. There are a bunch of reasons why you would want to have less code in your application. And then finally, this allows for you to do more experimentation. It allows you to try things out. It allows you to fail. It allows you to kind of do things you typically wouldn't do if you had to spend that time and money building things out, because there's no liability. You're just creating things, and then if they don't work out, you can just break them down, and there's no cost to you, really. And we're going to be talking about AppSync and Amplify for the most part, but this idea doesn't really apply only to AWS. I'm using AWS as an example, but if you have a cloud provider or you have a set of managed services that you like working with, by all means, just use those. We have our own suite of tools around this, but there are definitely other options out there. So this isn't only confined to AWS. What are some of the features of AppSync, which is going to be the first thing that we're going to be touching on here? It's a managed GraphQL service. So if you've ever wanted to get up and running with the GraphQL API, you can just spin up a GraphQL API with AppSync. If you've ever tried to build a secure real-world API with GraphQL, you may have run into issues around security, around authorization and authentication. There's a lot of stuff to think about, different things, especially around security, I would say. We kind of handle all that for you. Also, it is scalable and it just works. So you just kind of set it up and it's there. You don't have to deploy it or any of that stuff, worry about the infrastructure. We have offline and subscriptions built in. Offline is something that's on the client. Subscriptions are the GraphQL subscriptions that are just baked into the service. And then we spend a lot of time getting security right. So we have enterprise level security and fine-grained access control built in. We have real world enterprise customers using this stuff with millions of users. We've battle tested everything. A lot of people like the fact that we are really worried about security, and I think we do a really good job of handling that for you. And that's that's one of the main parts of AppSync. The other service that we're going to be looking at is Amplify, because in the React Native app that we're going to be building, we're going to be creating an AppSync service and an authentication service using Amplify. So Amplify is going to be the tool that we use to kind of get that up and running. So Amplify is a combination of a few things. It's a CLI, it's a client library, and it's a hosting and deployment service. The client library allows you to connect to and interact with cloud services. So things like authentication services, GraphQL APIs, storage, analytics, those sorts of things. We have pre-configured components for popular front-end libraries, and it's completely open source. You can contribute to it. You can also create issues and ask questions there. And we do it because we want it to be searchable and we want to be open in the development of the project. Also, you can fork it and do whatever you like with it. Right now, we have first-class support for iOS and Android on native, and for Vue, Angular, Ionic, and React Native on the web. But the main Amplify project is a web project. So you can use this in any JavaScript project, really. But we just have first-class components that we're going to look at for these frameworks. So we're going to touch on the toolchain and the client library before we kind of build it out, just to kind of give an overview of exactly what this stuff does. The CLI will allow you to create, update, and delete these services. So you'll create your AppSync GraphQL API from the command line. You can update and delete it, and then any other service you'd like as well. And then once we've created our API, we can generate all of the code that we need locally, so we can create the mutations, queries, and subscriptions that we're going to need in our JavaScript application. Instead of having to write all those from scratch, we're going to let the CLI do it for us after we create our schema. And then we're able to now manage multiple serverless environments. We just added this feature a couple of weeks ago. But essentially, if you have a production application and you want to build out a new feature or you want to test out something, you can clone the environment, try things out and merge whatever changes are back into your production environment. Some of the features that we also support other than GraphQL and authentication are chatbots, storage, internationalization, push notifications. We can work with AR and VR scenes. That's handled as part of the first class part of the library. You can interact with Lambda functions, REST APIs, analytics, and we've already talked about kind of the GraphQL and authentication, and that's kind of what we're going to be diving into in the example. So in the example that we'd like to build, we want to kind of start off with some of the main functionality you typically see in an application. So for the most part, when you build an app, you need user management. You also need some type of backend. You probably want search, and you also maybe want analytics or reporting. So we're going to be using AWS AppSync for the data store. We're going to be using Amazon Cognito for the user management. We're going to be using AWS AppSync as well for the search. And then we're going to be using Amazon Pinpoint for the analytics service. So now we'll jump into a brand new blank React Native app and start building some of this stuff out. So we're going to be building this app in 3 steps. First, we're going to create the Amplify project. In step 2, we're going to then add the services to the Amplify project. And then step 3, we're going to then implement the features from the Amplify into React Native. In step 1, I already have a blank React Native project created. Nothing going on there. I'm going to go ahead and run Amplify init to initialize a new Amplify project. Here we're asked for a project name. I'll call this Byteconf RN step 1 app. Now we can set a name for the environment. This is so we can in the future create other environments to do different work in, create features, and then merge back into our main environments. I'll start this environment as dev. Next, it's going to ask for our default text editor. This is so we can choose what editor we'd like our files to be opened up in by the CLI. So for instance, when we create our GraphQL schema, it will automatically open up in the proper editor. So I'll choose Visual Studio Code. For the type of app that we're building, I'll choose JavaScript. And now you'll actually start noticing that the CLI knows what environment we're in. So it knows we're in a React Native app. So it gave us JavaScript as the default. Now it's choosing React Native. It knows our source directory is not there. If there was a src or a lib directory, it would detect that. I'm going to actually just take the defaults for the rest of these. Now we've chosen all of our options, and we need to choose a AWS profile so the CLI knows which user to create the services in the name of. I'll go ahead and choose yes to use an existing AWS profile. When you first install the CLI, you'll run Amplify configure to configure these different users. The user I'm going to use is EU Central User. This is going to go ahead and initialize our project in the cloud. And while that kicks off, I'll go to step 2, which is really just where we left off from step 1 after the project's been created. So we don't have to wait for that to happen. It takes anywhere between 30 to 60 seconds. After we've created our Amplify project, we'll see that we have a Amplify folder. And in the Amplify folder, we have a backend and a current cloud backend and a team provider.json. This is just project configuration for the Amplify project that we've created. We also have an AWS-exports.js file. The AWS exports.js file is what you're going to use in your React or React Native application to let the application know about the different services that we've created. So after we've created our Amplify project, we should be able to run Amplify status. Amplify status will give us the info about our current project. Right now, we don't have anything there. We don't have any services enabled. We do have an environment that we've set called dev. We want to add authentication and a GraphQL API. So to do that, we'll run Amplify add API. Well, let's first run Amplify add auth actually to go ahead and add authentication. So it's going to ask us, do we want to use the default authentication and security configuration? We can either choose the default configuration, which is going to give us multi-factor authentication on sign up and then username and password on sign in, or we can specify our own configuration for things like the type of password we'd like them to use, what type of MFA we'd like, around 20 or so different options. I'm going to just choose the default for this example so we can kind of get going a little faster. So this created the local configuration for the authentication service. We can push it up to our account by running Amplify push, but first I'd like to add an API. So I'm going to run Amplify add API. This is going to give us the option between a REST API and a GraphQL API. The GraphQL API is going to be the AWS AppSync API. The REST API would be an option between two types. One would be just a Lambda function with an express server running in the Lambda function. The other would be a Lambda function with CRUD operations going to a data source. I think it's DynamoDB. So we're going to choose GraphQL as our API service. For the API name, we can call this BCRN AppSync. That sounds good. For the authorization type, we can choose either API key or Cognito user pool from the console, and in the actual, from the command line, and then in the actual AppSync console, we can also choose either OpenID Connect or IAM. So we have 4 different options. Since we already have a Cognito user pool set up when we ran Amplify add auth, I'm just going to go ahead and choose that Cognito user pool here. It's going to already recognize that we have a user pool configured, and it's going to go ahead and recognize that and use that. Now it's going to ask for a GraphQL schema. If you have a GraphQL schema locally, you can just reference it here, but I do not, so I'm going to choose no. Next, it'll ask us if we'd like a guided schema creation. This will kind of give us a few different boilerplate GraphQL schemas that we can start off with. I'll go ahead and choose yes for that. And then next, it's going to ask us what best describes our project, which is going to be why it's going to kind of say how the actual boilerplate there that we're going to be given looks like. So based on this choice, we'll be given a different boilerplate. The single object with fields is fine because we want to start off with something pretty basic. And do we like to edit the schema? Let's choose yes and go ahead and edit the schema. This should go ahead and open up the schema in our text editor. So I'll go ahead and zoom in a little bit. The schema that we're going to be starting off with is going to be this basic to-do schema, but what we'd like to build is a conference app that keeps up with conference talks and speakers. So I already have a GraphQL schema that we're going to start off with. This schema is going to have a talk. It's going to have a name for the talk name, and then we'll have a speaker name and speaker bio. And then we have an ID for every item. You'll also notice that we have this @model directive. This is part of the GraphQL transform library. This is something that is part of Amplify. We have 5 different directives that kind of go along with the GraphQL transform library. We have @model, @connection, @auth. We also have @searchable. So there's 5 different ones, and each one kind of does something a little different. @model will scaffold out an entire API using a base schema. So we'll get all of the different CRUD operations we typically need for a real-world application built out for us. So we'll not only have the type built out, but we'll also have the mutations, subscriptions, and queries that we would need for a typical application. For instance, we'll have create talk, update talk, list talks, get talk, all the subscriptions around those. In addition to that, we'll also have the resolvers that will go from the queries and mutations and subscriptions to our data source. So all of the resolvers will be built out for us. And then finally, we'll have the data source also built out for us, just from using this @model directive. I'll go ahead and save that and jump back to the command line. Now we should be able to run Amplify status and see that we have 2 new operations that are going to be created. Both of them are going to be create operations. One is going to be for auth, the other is going to be for API. Now I can run amplify push. And this will ask us if we'd like to continue. And we can choose yes to go ahead and create these two different resources. Now, since we're creating a GraphQL API, it's going to ask us if we'd like to generate the code that we need for our GraphQL API. We choose yes to go ahead and create that code locally. We can then choose between JavaScript, TypeScript, and Flow. I'll go ahead and choose JavaScript. And for the file pattern, we're asked how we'd like this to be created in our application. So we can give it a file path pattern that we'd like to go with. I'm just going to choose the default. And next, it's asking if we'd like to generate all the different possible operations. So queries, mutations, subscriptions, I'll choose yes. So this will take a couple of minutes. Since we're doing more than just creating a basic application like we did in step 1, this is going to actually be creating all of the services for this application. So we'll go ahead and jump to step 3, where I have a final AppSync project created with these two services and a React Native app running, a basic React Native app. So if I run amplify status here, we'll see that we have our API and our auth already created, and we should not have actually any change for our operation. I'm not sure why this is on update. I may have made a change there in the schema at one point, but basically once you have your different properties or your different services created, you'll have the operations of either no change, update, or delete, depending on what you're doing. So now that we have that created, let's jump to our React Native app and start writing some code. So in our React Native app, we have a basic empty React Native shell and nothing really going on there. It's just the new project you get when you create a React Native app. The first thing we want to do is we want to add authentication. To do that, we'll go ahead and need to let the project know that Amplify is available and we have some configuration we'd like to add to this project. To do so, we'll import Amplify from the AWS Amplify library here. We'll import the AWS exports file that we saw that was created for us by the command line. And then we'll call amplify.configure, passing in the config. This is something that we do at the root level, so we do it in index.js. After that, our Amplify project has been initialized, and we don't really have to worry about this anymore, so I'll go ahead and close that. Give it a refresh. And now we see that we have everything still working, so we didn't break anything. So I'm going to go into app.js and start deleting some stuff to make a little more room for our actual code that we want to write. So deleted pretty much everything that we're not going to really be needing, just to have a little bit more room. So the first thing we'll do is to add authentication, we're going to be using the with authenticator higher order component. So AWS Amplify, like I mentioned earlier, has a few different client libraries. So we have React and React Native, but we also have Amplify Vue, Amplify Angular, Amplify Ionic. So we're going to be importing from the Amplify React Native library this higher order component called with authenticator. This gives us a really nice scaffold for an authentication flow. And instead of exporting the class as the default export, we're going to instead take the with authenticator and make the with authenticator the default export. So here we're doing a default export default with authenticator. We're passing in the app component. And then we're passing in a second argument of include greetings set to true. And this second argument, this object that we're passing in, is a configuration object. The with authenticator has different configuration that we can do really around stalling and stuff. The include greetings is just going to pass in a sign out button for us. So if I go ahead and refresh, we should now see that we're protected from using an authentication flow. So now I'm going to go ahead and sign up for our account. All right, after signing up, we should now get an email with our authentication code. And I get an authentication code here. So I'll go ahead and paste that in and click confirm. So now we should be able to log in. And there we are. So when I refresh, we should see that we stay logged in. Our user is persisted, so that's good. So now we want to access the GraphQL API we created a moment ago. So we're doing a conference talk app. So what we need is a form field. We need a way to keep up with the user's input that as they type into the form and the state. We need to fetch the data when the application loads. So those are like the three main things that we need. So before we can do any of that, we need to import the APIs that we'll need from Amplify to work with those API calls. So the things that we'll be importing are the API class and the GraphQL operation helper from AWS Amplify. The API class has methods like API.get, put, update, and delete, but we also have an API.GraphQL API that allows us to work with GraphQL APIs. And then we have this GraphQL operation helper that basically takes a query string and turns it into AST for us to create different GraphQL operations a lot easier and a lot cleaner. Then we have the operations that were created for us by the CLI. So we have this GraphQL folder that was created for us. And we have queries, mutations, and subscriptions. So we have all these different operations. We're going to be importing the list talks query and the create talk mutation. And then we're going to be importing a few components from React Native elements. We're going to be importing a list item and a button and a form input to kind of make our UI creation a little cleaner. Next, we'll go ahead and create some state. The state that we're going to need is an array of talks to keep up with our conference talks. We're going to need a way to keep up with the talk name, the speaker name, and the speaker bio. So we'll hold all of that into the state. Next, we're going to go ahead and import the methods that we're going to need to keep up with all of the different changes that we're going to be working with. So for instance, the onChange handler. So when someone types, we're going to be updating the state with the name, speaker name, and speaker bio. So we're getting in a key and a value, and we're passing in the key and the value in a set state call. In component did mount, we're going to be calling the API. So we're going to be calling the API by calling API.GraphQL, passing in the GraphQL operation and the list talks query that we imported at the top of the file here. Once the data comes back, we destructure it and pull out the items array. And then we call set state, passing in the items array as the talks value, and then we just log that out. So we're fetching the talks data and then updating our array and component did mount. Finally, we have the create talk method. This is going to be the method that calls a mutation to the API. So we first create a talk object, setting the name, and speaker bio. Then we do an optimistic response by updating the local array of talks. So we take the existing array, spread over it, pass in that new talk, and then we call set state, updating the talks array. And then we call also set state to update the name, speaker name, and speaker bio to clear out our form. So we do the optimistic response, clear out the form. Only then do we then call the API. So we're calling API.GraphQL again. Instead of passing in the query, we're now passing in a mutation. And the second argument is the actual data we're passing into the mutation. And that data is this talks object, or this talk object we created earlier. If that's successful, we'll log out something, and if it's not successful, we'll also log out something. So that's the create talk method. Finally, in our view, we're going to need some UI. So the UI that we're going to be having is just 3 form inputs. So one for the talk name, one for the speaker name, and one for the speaker bio. These are bound to the onChange text, the onChange handler that we created earlier to the onChange text handler of the form input. Next, we have a button that's going to handle the API call for create talk. And then we just map over the items in the local array of talks. And as we add talks, this array is going to grow. And then finally, I'm going to update this container to delete some of the styling so it looks a little nicer. All right, so refresh. We'll see what this looks like. So now we have a pretty basic form with the create talk button. Create talk. We get the optimistic response, we get the UI cleared out. If I refresh, then we still see that there. Create another talk. Everything seems to be working, so we refresh, everything is cool. So we have the queries and mutations working. Next, we want to look at subscriptions. And subscriptions are going to be like the real-time part that a lot of people want AppSync for in general or GraphQL for in general. So to do that, we're going to actually go to the AppSync console and look at the resources that were created in our account. So I'm going to go to console.aws.amazon.com. Here, I'm going to look for, first of all, Cognito, because this is going to hold the Cognito service that we created earlier for our authentication. And then I'm going to also look at AppSync. In AppSync, we see all of the different APIs we've created. The app that we're going to be working with, I think, is this one right here, BC AppSync Conf. And let me double check that by clicking on the data source. Okay, right. So this is perfect. This is the right data source. So we have our 2 items there. So this is the API that we created using the Amplify CLI. So there's a corresponding resource for any resource you create on the CLI in your account, of course. This is the AppSync API. So here we can do things like view the data sources for the API. We can update resolvers on the right-hand side. We can change our schema or view our schema. We can add a function, which is a new feature that we added recently. Allows you to take the response or the value of whatever gets processed in your resolver and pass it on to multiple functions. So instead of just being left with a single data source, you're able to access multiple data sources with a single resolver. Queries is a graphical editor. This is what we're going to be using to trigger a subscription in just a moment. And settings, just some general settings around your API. So I'm going to go to queries, but before I can create a query, I need to first log in. And I can log in using the user ID I created earlier, but I also need a client ID. This is something that we can get done in the Cognito dashboard. So I'm going to go to the API we created earlier, or to the Cognito user pool we created earlier, and I'm going to go to App Clients. And I'll create an app client for Amplify AppSync testing. And I'm going to unclick Generate Client Secret. And this will give us a client ID that we can use. And now we can just log in using this client ID and the username that we used earlier to sign up on the client application. So now I can create another mutation. Should be able to refresh and see the new data come down. So now we see that we have 3 items. What we want to do now is we want to test out our subscriptions using this. So the way that we'll do that is I'll create the code for the subscriptions in the app, I'll refresh, and then I'll come here and create a mutation, and we should see the data come through in real time. So to do that, I'll first import the subscription. Next, I'll grab the code for the subscription and we'll put it in component did mount. We'll subscribe to the changes there. I have this saved here to my clipboard or to another file. Go ahead and copy that, paste it here. So in component did mount, we're also again calling api.graphql. This time we're calling .subscribe on api.graphql as opposed to returning a promise, so doing an await. And every time a new piece of data comes in, we're going to be calling this next function. This will give us the data from the next function. And we're only subscribing to when a new talk gets created. So you can also subscribe to when a talk gets updated or deleted. We're just right now worried about when a talk gets created. When a talk gets created, we're going to create a new array of talks using the existing talks and passing in the new talk that's coming in from the event data. The way that we're doing this is we're filtering through all of the different talks and we're making sure that there's no duplicate values. This is probably not the best way to do this in real life. You probably want to do a client ID. So when the client ID gets created locally and then a subscription comes down, you double check to see that those client IDs are not identical, and that's the way you would do the filtering versus this. But for this example, this is an easy way to do that using our existing schema. So now I'm going to go ahead and save the new updates and refresh. So now we see everything still looks like it's working. And I'll go ahead and create. And this will be the last talk that we're going to be adding. And there we see that when we create our mutation, the data comes back in real time, our subscription updates and our UI updates. And then if we refresh, we see that everything is working. So that's kind of it. That's a really brief overview. The next level of working in this workflow would probably be getting acquainted with authorization and fine-grained access control. We already have now access to the user because now that we've set up authentication, the user data is now available to you in the resolver. So look into how to access the user in the resolver and kind of look at the authentication, authorization, and security documentation around AppSync. That's going to give you a lot of information about taking this up to the next level. Thank you for watching this talk and for coming to Byteconf React Native, and follow me again on Twitter. I'm Dabit3, and enjoy the rest of the conference.